Welcome to day 2 here at IPC Apex. As I said yesterday, it's definitely got a lot of new high-tech innovations at this show this week. And we're going to start off today with our first guest, who's Dennis Barbini, old friend from the industry. And Dennis, you've started a new company over here in the United States called Laser Cell, a South Korean company, and you're the general manager for the United States. Tell us a little bit about the technology that you're introducing.
Thank you, Trevor, for having me here. It's a pleasure to be here at Apex, sharing our new technology. It's our first time exhibiting here in the U.S. Our technology is a selective laser process. We are looking at reflowing, let's say, odd form, fine-pitched, thermally sensitive components.
Right.
That we see a lot of growing areas of interest here in the industry with IoT and wearables and other type of niche type applications.
Okay. Laser soldering's been around for quite some time, but one of the issues with it has always been the fact that it's temperature, the burning issue you get on the laminates and that type of thing. What have you done to address that issue?
That's a very good question. We hear that all the time. What we're doing here is, what's unique to our technology is that we take a laser, an IR laser, and we put it through one of our beam shaping optical modules. In doing so, we disperse the energy over an area that is defined by the optics.
Right.
So whatever application it might be, we might be able to do a 4 millimeter by 4 millimeter square, or sometimes same area of a rectangle, or we can go all the way up to 80 millimeter by 80 millimeter.
Right.
So we have two different types of these optical modules, fixed design as well as variable. So we can adjust accordingly to the application. That uniformity of energy that's dispersed is greater than 95%. So we are very effective in delivering a certain amount of energy over a certain area very uniformly. So we can reflow solder without damaging any of the components, the board, or the solder itself.
So these modules essentially don't reduce the power getting to the joint, but they take a lot of the heat, or disperse a lot of the heat out of the situation.
Well, yeah, we are taking all the energy that's in that one spot and diffusing it over an area. Therefore, we are reducing the amount of energy concentrated in that area itself.
Okay. So so let's talk about the way that you actually do this. You have a couple of examples.
Yes, so we have a couple examples. First of all, setting up the process. Setting up the process is actually very simple. It's similar to, you use the same tools that you would use in a mass reflow profiling system. So you use your thermocouples, your recorder, you put your thermocouples where you need them to be.
Right.
And you try and optimize the process. In our case, the process goes from a 6-minute reflow process for forced convection down to about 5 to 10 seconds for the laser process. So it's a little bit different, but we're using the same tools. But we also add on an IR camera because this is an infrared laser.
Right.
So we can monitor the temperature as well using the camera. But other than that, you go through a stepwise process of optimizing it and getting your profile that you need.
So how easy is that to set up? I mean, is it just, how do you teach it?
Well, like you would in a typical user interface, we have a program where you plug in the steps that you want to have. When the board comes in, you're looking at a specific component, you optimize the process, it saves it as a file, and then you can recall it whenever you need to.
Right, okay. So, I mean, one of the beauties, obviously, of this system is going to be it's a much smaller footprint. Looking at some of the applications for it, you're able to do much smaller sensitive devices as well as some large odd form devices.
Correct.
So a lot of companies maybe have a reflow oven there, which is supported by an old wave soldering system for doing the old odd forms. Are you saying that using this new laser system, you could pretty much do away with the wave soldering component, have this plus a few extras, for features for doing sensitive devices in hard to get to areas?
Well, I would say that we are not going to be replacing reflow or wave soldering anytime soon.
Right.
But I think that we have areas where we can certainly do the complex components that reflow and wave. They pour a lot of energy into the board, where we can just apply energy where it's needed to do a certain task.
Right.
So in that case, we are enabling end users to do things that they've never been able to do before.
Okay.
But we do, for very fine pitch, for thermosensitive, we can make sure that we address the issues of those components, optoelectronics, fine pitch. We've proven that this technology mitigates some warpage. We also have other devices that can eliminate it. We also have opportunities in odd form, like I mentioned before. So we have an array of different applications where we can selectively put the energy in, but outside of that area is going to be completely cold.
Right, because
less
the
100
process
degrees.
is so fast, it doesn't allow enough time for the thermal transfer to go down into the board.
There's that as well, but because we're only shining the energy in one area, there's no bleed over because it's very fast, as you mentioned, and it's also, we're only optimizing the process to get the energy into the solder joint to form a properly coalesced solder joint, and then we're done. So energy doesn't flow into or around that component.
So you avoid oxidation into the solder joint.
Yes, we don't use nitrogen, and we use a fraction of the electric costs that you would do for a mass reflow process.
Right, right. Have you got any of these systems in the field at this point?
Yes, we do. We have systems over in Asia, in China, Taiwan, Korea, Japan. So our coverage is out in the Far East at this point, but we are actively doing evaluations here in the U.S. So we're welcoming the opportunities as we speak.
Great, great. Well, it sounds a superb new technology, Dennis, and we wish you every success with it.
Thank you very much.
And thank you for introducing it to us today.
Appreciate it.
Okay, thank you. Coming up after the break, we're going to be bringing you some more new tech from Apex.
Sponsored by Panasonic. Smart factory solutions for any mix, any volume. Introducing the new NPM W2S, the ideal placement solution for manufacturers who value reduced setup and changeover time over volume.
And welcome back. I'm joined by Craig Result from Octane Open Concept. You've got a new technology that you're going to tell us about that gives a visual interpretation of your MES system.
That's correct. So what we do is we take a Gerber file and we draw a pictorial image of the circuit board, and we use that with the data in the MES to populate it, change the colors so that it's real time. Put it as a 60-inch monitor or whatever above your line, have it on your cell phone, whatever, but you can troubleshoot your line at a glance.
So you're getting a visual representation of the board as it's going through the manufacturing process. If they get a high thermal map or something like that,
yeah, so
up on the screen.
Anything that fails throughout your process, so whether it's at SPI, AOI, ICT, your functional test, anything that'll report up to a reference designator to your MES system, or we can create a database and just report it without an MES, but needs to be in reference designator form so that you can see it as it's drawn up onto the picture.
I see. So if the inspection system flags it up, it then comes up as a color representation on the map.
That's correct, a picture of the board.
Okay, great. You also have a thermal map function to it. Tell us how that works.
Yeah, so we can do the thermal or heat wave actual image of the board, and it's everything that happens throughout your shift, however you have it set up, through a day, week, whatever it is that you want to do. And if you run a board in panelized format, and I need to know that, hey, board 1 in the upper left-hand corner seems to be having lots of solder shorts, simply go straight to the screen printer. Make sure that all your pins are in, that you have good support. You can fix the problem. Stop the boards from going to repair.
Right. Okay. So this is an add-on to the MES system. It's you don't. It doesn't actually generate any data of its own. It's just a pictorial.
Correct. We just pull the data directly from the MES and turn it into a picture.
Right. Right. Now, and that can be accessed on any device, cell phone, iPad?
Cell phone, iPad, Surface, whatever you want. Is anything that'll pull a browser, you can have that information right at your fingertips.
Excellent, excellent. Okay. So I'm assuming you've had many years of experience in the EMS business, that this is where the idea came from.
Yeah, 22 years of pain and suffering on the manufacturing floor is kind of what spawned the entire process here.
Right.
We have two products. The first one we've talked about is Heatwave, and the second one is a slide line documentation. every now and then people just don't show up to work, and our automatically rebalances the load,
Right.
And changes all of the documentation in less than a second.
In less than a second. Wow, that's amazing. Great. So you're a fairly new start. You've been going only about 5 months. Do you have any systems in the field yet?
So we have 2 systems in the field that are running all of our tests and data. We want to make sure everything's perfect before we roll it out. We have 3 more rollouts happening here in the next month. To some other contractors, and once we've got all the testing done, out live.
And it goes. Great. Well, it's a great idea, and it's very visual. You can actually act on it immediately. So congratulations.
Thank you very much.
Thank you for sharing with us today.
Thank you.
Okay. And welcome back. I'm delighted to be joined now by the IPC's Head of Government Relations. That's Chris Mitchell. Nice to see you, Chris.
Thank you very much.
Okay. Now, let's talk to start with your role as a global ambassador for IPC. IPC's been very active, of course, in Washington for many years, but now you've opened an office in Brussels.
Yep.
You're working with the European Union. You have your own division, of course, in China. And there's a lot going on. So let's start to unpack some of that, starting with European Union. What are your goals interacting with the European Union?
Well, as you mentioned, we opened an office in Brussels last year. We have a senior director that is our chief advocate for the industry there. And we really have 3 priorities right now in Europe. The first is environmental regulation, ROS and REACH, obviously a big issue for our members globally, because these laws really do have global impact.
Absolutely.
And so we're working to help shape the contours of those regulations and make sure that the industry is well represented. Secondly, workforce. Workforce, again, a big issue in the United States as well as in Europe.
Yes.
And in fact, next month, we are getting ready to launch an initiative there in which we are looking to, in which we're going to commit to providing workforce training opportunities for 500,000 Europeans over the next 5 years. And so that's an exciting initiative. We did something very similar here in the United States, and so very excited about that. And it's going to not only entail greater engagement with our industry, but also at the university and high school levels. So very excited about that. And then third is responsible minerals, responsible sourcing of minerals. This is in the United States we've referred to this as conflict minerals.
Right.
Right now, the EU is looking at how they're going to handle this issue. The IPC has some data exchange standards that we'd like to see both recognized by the OECD as well as the EU. And we're also looking at partnerships. We want to be proactive on this issue so that as the EU looks at appropriate regulations, they take into account the constraints as well as the goodwill of industry to try to tackle this problem. In the United States, we were very much on the reactive, in part because the regulations really came out of nowhere. Right, and so so those are our 3 priorities in Europe.
Right. I mean, I think it's great that you're getting ahead of some of this legislation, because this was historically the issue, especially when we had RoHS come in and it literally cost the industry billions in change, and quite frankly, a lot of people still don't think it was justified at the time. So it's great that we have a trade body there that is actually representing our requirements and getting ahead of the legislation and maybe talking some sense into these politicians. Of course, you're absolutely right. The talent sourcing issue in the United States and Europe is a massive issue, and it's really laudable to know that you're doing something about that as well. The big global issue, of course, that's on everybody's lips at the moment is the the trade negotiations between the United States and China. What is the IPC view on this situation?
Well, IPC is all about growing the supply chain globally.
Right.
And trade, tariffs, I should say trade is critical to that, right? So tariffs and other trade barriers are problematic from our perspective. And trade barriers can come in many different forms. They can come in the form of tariffs. They can come in the form of discriminatory trade treatment, unfair trade practices. And so we want to work with governments globally to try to address these trade issues. In the case of the current trade dispute between the United States and China, we have encouraged both parties to negotiate. It'd be great to see a bilateral trade agreement between the two countries. That may not be a near-term option, but that's the direction we'd like to see things move. The U.S. and Chinese officials are meeting this very week to try to
as we speak.
Exactly, to try to work out some of these issues. I don't think that we have a lot of optimism that we're going to see long-term significant breakthroughs over the next few weeks. On the other hand, we are hopeful that we'll find a pathway for future and ongoing negotiations so that we can begin to address these trade issues and ideally seek some relief for all of these companies that many of whom have been harmed by the tariffs.
Let's talk about some of the ramifications of this. I mean, as I said off camera, even before the tariffs came in, there was some evidence of some manufacturing moving out of China because of the higher labor rates, going to places like Vietnam and Indonesia. But one of the effects of the tariffs seems to be driving some business to Mexico. Now, Mexico obviously has more trade agreements, I think, than any other country in the world, free trade agreements. So it makes sense for manufacturers to bring a lot of the components from China for assembly in Mexico and then pay just one tariff when they bring it across the border to the United States. Are you seeing evidence of this?
We definitely are. I mean, I think we're seeing the same trends you are. I just had to make 2 points. Number one, businesses are going to make business decisions, right? And in the response to these tariffs, we have seen companies that have decided that in order to avoid these tariffs, they are going to need to shift their supply chains. And in many cases, that means taking work that is being done here in the United States to Mexico, where the substantial transformation takes place, and then the goods are imported into the United States without the imposition of these additional tariffs on China. And so we definitely see that taking place. To your point, I think we also see renewed interest or greater interest in Mexico as a source for manufacturing and some of this assembly work. Our view is that the North American marketplace is really critical to U.S. manufacturing. Right, and there has been a very concerted discussion here in the United States about how we really revitalize U.S. manufacturing, and I think our trading partners, Canada and Mexico, are really critical to that effort. So this year we're really focused on making sure that the U.S.-Mexico-Canada agreement passes Congress, and again, what more can we do here in the United States and in Mexico and Canada to make sure that we bring greater integration between our countries so that we can really capitalize on these global trade opportunities. Right.
Well, I'm sure the tariff situation and the negotiations are not helping your ability to interact much with the Chinese government for technical issues. I'm assuming that's part of your role as well. You're interacting with the European Parliament, to try and have an influence on technical legislation. I'm assuming that's going to be part of your goal in China too.
Yeah. Well, I would say that we have an existing. We have about 1,000 members in China. We have a number of offices there. We have a very positive working relationship with the government in China, and I will say that as a global organization, we are committed to a global public affairs program. Our main goal is to make sure that we are partnering with governments wherever possible to make sure that we grow this supply chain and we grow this talent pool. Right. And so we are, again, these kinds of trade issues and any kind of tensions within the foreign affairs space can be problematic from the industry's perspective, but we are committed to working with governments globally so that we can grow this industry.
Yes. Okay. Yeah. I mean, I think tariffs are usually a blunt instrument, but they seem to have had an immediate effect in this particular case. So I think that the sooner that it's over, the better.
Well, there's no question that the actions of the United States and the response from China have really driven the two sides to the negotiating table.
Yeah.
And again, we'll have to see how the two countries can move past this point.
Yeah.
And I think that from an industry perspective, that's what we're all hoping for, so that we can have a level playing field.
Yeah.
And that the industry can thrive globally.
Yeah. Great. Great to get your perspective on things, Chris, and thank you for joining us today.
Thank you so much.
Okay. So that brings us to the end of our morning program here from IPC Apex. Join us tomorrow morning for more news from the show floor.